Mario 64's exclamation mark boxes waste 24 times as much memory as they should and render 2 to 7 times slower than they should. Now, they are a small asset, so you may think there isn't much that could go wrong. But like almost everything else in software development, they have huge inefficiencies that we are going to iron out. Now, don't get me wrong, these boxes inflate the performance budget about as much as leaving on the lights during vacation inflates your electricity bill, but I am making a complete sequel to Mario 64 with every asset remade and the full engine rewrite, so while this 24 times improvement in the grand scheme of things is an unimportant micro optimization, if we can improve the situation and get nicer visuals, why not? And if we do hundreds of these optimizations, who knows, maybe they add up to a sizable performance improvement. Maybe you'll end up with a game that easily runs at twice the frame rate with nicer graphics. Usually I explain more complex optimizations than this on my channel. After all, 6 sides, 8 vertices and a texture. How much could really have been wasted here? It is such a simple asset. As it turns out, a lot. Let's start with the basic premise of optimization. Your program can only run as fast as your slowest process. And on the Nintendo 64, the slowest process is always data transfers. So that's all we really need to care about. So let's see where we can save data transfer cost on this box. We will start with the actual 3D geometry. The box is, as you would expect, 6 sides with 2 triangles each. Because the box takes a lighting parameter, each vertex of the box stores the lighting direction at which it will receive the most light. The box uses hard shading. That means vertices are split, and we need to render each side as 2 triangles with 4 vertices each, for a total of 12 triangles and 24 vertices. In my last video, I explained that we can split edges like this without duplicated vertices using the flat shading mode, and we could be using this mode to reduce the vertex count here too. Unfortunately, the Nintendo 64 modding community's current tool does not fully support this feature. So while technically this is reducible, we don't yet have this technology. Too bad. But there's other places to look at. Next is the textures. There's an absolutely insane mess with the current texture here that we can clean up. There are 2 glaring issues. The first is that this box actually uses 2 separate textures. One for the top and bottom, and one for the exclamation marked sides. The one with the exclamation mark is a 32 by 32 texture, while the top and bottom texture, the one with less detail, is 32 by 64. This is not only bizarre, but also wholly unnecessary, as a much better usage of texture space would have been something like this, that simply puts both into one texture. Here's the new texture compared to the old 2, and I bet you cannot tell which one is which. This also avoids having to use more than one texture per object, which is a huge no-no as far as optimization goes. But before we finalize our decision on that, I want you to notice the second issue on this texture. The texture is yellow. Well, I mean, obviously, right? But that does mean there's 3 more copies stored of this texture in blue, green, and red. But the N64 has much smarter ways to color textures than to naively store textures with colors pre-generated. And that's what we will do. Not doing this quadruples the storage requirement here. And just like on the yellow one, the top and bottom texture are twice the size. But wait a second, something looks off here. Why are some stretched vertically instead of horizontally? It is bizarre, and just for fun, here's a comparison between a vertically and a horizontally stretched exclamation box texture. I cannot really tell the difference, and I suspect the developers simply didn't notice this. Put it on the iceberg, I guess. What I do notice a difference with though is this video sponsor, Raycon. I've been using them on my walks recently, and they allowed me to get done listening to my first Queen album while walking. They're 20% off right now for the holiday, and they make a great holiday gift. They sit directly on your ear, so you get clear sound even without blocking outside noise. They have 3 million customers, and their sound quality is just as good as the more expensive brands. Even better, if you don't like them, they have a 30-day guarantee. They're easy to pair to any phone you own, and they allow you to switch between your devices without repairing too. They have 8 hours of playtime, and I honestly forgot I was wearing them a few minutes after putting them on. Click the link in the description or go to buyraycon.com/CaseN64Open to get up to 20% off site-wide. The original textures in total have 3072 pixels. At 2 bytes per pixel, This means we need 6 kilobytes of data transfers to render this box. And since we store all these textures 4 times, we need 24 kilobytes of size just to store the textures. The first thing we want to do to improve the situation is to make a shader that can color in a texture. Well, actually, the Nintendo 64 doesn't have shaders. Instead, we have a fixed function pipeline that we can configure with our own parameters. This is sort of a predecessor to shaders. Parameters can be something like a texture, a light color, a vertex color, a texture's alpha channel, or even 2 configurable colors. BioBack actually reworked this model here, and it wasn't all me, and he opted for this combiner that I will briefly explain. Primitive color is one of those 2 configurable colors, and this will give us a nice yellow color here. For fully transparent pixels, this combiner runs this math formula and simply outputs the primitive color in the first cycle. For fully opaque pixels, it runs this math formula and outputs the texture's color in the first cycle. In the second cycle, we then multiply with the shade color, which is the lighting in the level. For anything in between, we get a value between the primitive color and the texture's color. That means we can use our texture's alpha channel to decide the percentage of color on the box and the color channel to paint shadows and highlights. This gives us a box that looks like this, and we can then play with the primitive color to color it in any way we want. Party party! Of course, we need to talk about the textures we are going to use here too. A naive approach would be to use a texture kind of like this to render the whole thing. Since the texture is now grayscale and the grayscale format only uses 1 byte per pixel instead of 2, we can easily use a resolution of 32 by 96 to get an exact looks match without any further adjustments. But BioBack had a different idea to get more detail while actually reducing the texture size. This is what the box part of the texture looks like. It is not even 32 by 16 pixels. We simply enable texture mirroring on the x-axis to get a whole stripe up here, and clamping on the y-axis to use the bottom part here to get the fully primitive colored middle of the box with some highlights and shadows around the rim. Unfortunately, as I'm sure you can already tell, this does need 2 extra triangles via subdivision on each side. This doesn't really matter too much though, as we will see later when we do a performance comparison. The exclamation mark is added as a rectangle in front of each side of the box, using the same mirror wrapping, which, yes, that does mean another 8 triangles. The texture is now 16 by 64 pixels, but because it has no color, this only needs 1 byte per pixel for a total of 1 kilobyte of texture data. That is a 24 times improvement in terms of memory usage compared to the previous exclamation mark. I am so whopped right now. Here's also a side-by-side comparison between the new and old box. Holy shit, nice work BioBack. The observant viewer will also notice that this gives us a total of 32 triangles on the new box compared to the 12 triangles on the old box as a downside. So let's actually compare the performance between these 2. For complicated reasons I'm not going to get into, 1 triangle costs roughly 105 bytes of memory transfers. So we effectively traded 2100 bytes of triangle data for 5120 bytes of texture, and they have total gain of around 3 kilobytes. Very nice, this would already be a 40% performance boost, which sounds nice, but keep in mind, we now only use 1 texture instead of 2, which has huge implications when we render more than 1 box. Since we no longer have 2 textures, it means we can render any subsequent box without reloading the texture. This is something that's relevant even in modern game development, and you will frequently see game developers put all the textures onto an atlas like this to map onto their models. This is a gigantic speedup, as now the texture load penalty for the second box drops from 6 kilobytes in vanilla Mario 64 to literally 0. Of course, our box still has more triangles, so any subsequent box, we will only see a 70% improvement with our chosen texture. With the theoretically lower detail texture we don't use, this would be an 80% improvement on the second box over the vanilla game, by the way. So that may be a nice performance but lower fidelity option. Not that we would need it, but the option exists. As a cool little bonus, we can now much more easily add new box colors. So here's the light blue, black and white box for the new free power-ups that I have added to my game. We are done with the visuals now, but I am also working on remaking all the code in Mario 64 in my own way to get to 0% Nintendo code for the final version of this game. aside from maybe some of Mario's physics that simply have no other way of being implemented. So the box code had to be remade too. There were a few goofy decisions in the code too, such as this array of box contents that were numbered through, and the numbers were compared against instead of simply indexing into the array for no good reason. Look at the screenshot, that is a lot of code to program what is effectively just this one line of code. The rest of the code was mildly inefficient too, so I was able to roughly half the size of the code while adding some new animations and more accurate collision. And just for the fun of it, here's my game rendering 200 exclamation mark boxes on a real Nintendo 64. It starts at 25 FPS, but even my improved engine drops down all the way to 19 FPS when I spawn enough coins. This is kind of an extreme situation though. We have over 6,000 triangles just for one texture. Absolutely not representative of real-world game use scenarios. So the big 70% performance improvement we would expect to see in normal game usage is not quite visible in a scenario like this, because here the RSP and not the memory would become the bottleneck. Just for the fun of it though, here's the base Mario 64 game rendering 200 of its exclamation mark boxes, and even that one manages to hit 16 FPS before it inevitably crashes when you try to open a box because the game cannot handle that much stuff. And that's it, there isn't much more we can do here. After all, it is literally just a cube. No reason to overthink it. Shoutouts to all my patrons for supporting this project. Patrons will be credited in the endgame credits of the Nintendo 64 game I'm working on. If you want to follow active development, you can actually check out my second channel, where I stream work at least once a week and upload new feature progress twice a week. I also have this progress tracker document, so you don't have to ask me for release dates. See you guys in the next video. Bye bye.